Hello everyone. Today I want to continue on the topic of why is DeepSeek cheap and good. And the third episode is going to be about FP8 mixed precision training. If you like my videos, please subscribe, comment, and like. Thank you. Let's dive into it. So before I start with FP8, I want to talk about FP16, which is more popular in AI world. So FP16 refers to a 16-bit floating point. Normally programs run with 32 or 64-bit numbers. If you're a programmer, you should be familiar. And by using FP16 to represent model weights and activations, it allows faster computation and significantly reduced memory usage. So in summary, the advantages are smaller memory footprint. FP16 needs 50% of memory compared to FP32. And this enables large batch sizes and models to fit into GPU memory. It is the main reason why it's so popular in GPU and AI training. It comes with faster computation. So many GPUs are optimized for FP16 because of the smaller memory usage. So this allows accelerated matrix multiplication without significant degradation in accuracy. The next one is acceptable precision. Although it halves the bits compared with 32 bits, it still retains enough dynamic range and numerical stability with proper handling of quantization. So quantization is the process of mapping continuous infinite values to a smaller set of the discrete finite values. You're gonna see quantization quite a bit later, so I want to explain it a little. And usually when you translate higher bits to lower bits, you could run into quantization underflows and overflows. And those are bad things, of course, and I'm gonna go through it later in the following slides. So now we have FP16 from FP32, and we have all those advantages. So can we do better? Let's try FP8, right? It's the apparent or intuitive thinking. So that's what a lot of other people also think. FP8's advantage is even smaller memory usage, right? There's another 50% off, and then it also with higher throughput, because training with FP8 enables faster computation, smaller data types, reduce the data transfer time, and allow for more like flops. And flops is what matters in training a model. And it comes with lower energy consumption. Energy consumption is actually one of the major concerns of training large models right now. However, the transition from FP16 to FP8 is tricky. FP8 has several unique challenges compared with FP16. One of the main reasons is FP16 is an established model in both software and hardware, so it comes with a pretty stable ecosystem for like most models and hardwares, and FP8 doesn't have it yet, and it's starting to catch up. So I want to talk about FP8's challenges. The first one is numerical instability, and this is where we are going to talk about the quantization, underflow, and overflow. So it mainly refers to the gradients when we do training. So during backpropagation, which is one of the essential steps of machine learning, gradients can become extremely small. So FP8's reduced range can't represent these values accurately, so this could lead to unstable or non-converging training. So a value during the process of quantization becomes smaller than the smallest value, smallest representable value allowed by the data type, which is FP8. So essentially resulting in the value being rounded to 0 due to the limitations of precision. This is a very bad thing because small values is critical for like fine-tune updates. And there usually are a lot of sensitive layers in large models, and small value is very important, and rounding to 0 is not acceptable. The next one is gradient overflow. It's similar with underflow, it's just gradients can become extremely large, and the problem is it exceeds the maximum representable value within the chosen data type, which is FP8. So it essentially overflowing the allowed range and resulting in an inaccurate representation. So it's a type of error that can occur when a value becomes too large. And this is also a pretty serious problem. So how DeepSeek solve this? They have a blockwise quantization scale. So first of all, to prevent overflow, we usually scale to higher precision weight or activation matrix down to the FP8's representable range for quantizing. How to do it? The easy way is just to divide by the maximum element, by the maximum value. And the maximum element is kept separately and used as a scaling factor in each matrix multiplication. Or GAN, it's basically the same thing. However, this makes the quantization process very sensitive to outliers. So the presence of a very large weight in some layer could force all other weights to be quantized to 0. Right? If in one layer your value is very large, let's say 1 million, but in all other layers your value is all single digits, then your maximum value is 1 million, and then you have to divide by 1 million for all the weights. Then only one layer will have value. All the other layers will be basically 0, right? So this is very bad. So what DeepSeek does is it introduces blockwise and tile-wise scaling, in which each submatrix or subvector are scaled and quantized separately. So that's how they solve this problem. Next FP8 challenge is error accumulation. So this related to the first challenge actually. So errors introduced due to FP8's lower precision can propagate and accumulate through layers of the model, compounding over time and seriously breaking the quality of the model. When, like nowadays, modern AI models usually are large and like transformers, they have a lot of hidden layers. So the errors accumulate very fast across those layers, and the error becomes pretty big and the quality impact is pretty bad. So DeepSeek solve it by mixed precision training. And this is their mixed precision training pipeline. You probably don't have to know all the details behind it, but it's pretty obvious they have all kind of like precision here. You see FP8, FP16, FP32, right? So in summary, they have FP2 accumulation, matrix multiplications, matmul or GEM are performed in FP8, but the accumulation of results is done in FP32 for higher precision. And they have a hybrid precision, so model weights are stored in FP8, but the activations and gradients are stored in BF16. This balance helps preserve important information during training. And FP32 is also used in some internal computation. So the last FP8 challenge I want to go through is the hardware limitation. A disclaimer, I'm not an expert in hardware, so a lot of information I pulled from DeepSeek's paper. So you can ask Gemini or ChatGPT if you have more questions, or you can comment and I will try my best to answer it. So hardwares like NVIDIA Hopper architecture, which is what DeepSeek used, they're starting to support more and more of FP8, but there are still a lot of gaps for optimal performance. The low precision math multiplication or GEM often suffer from underflow issues, and their accuracy largely depends on high precision accumulation, which is usually FP32. So, however, DeepSeek observed the accumulation precision of FP8 matrix multiplication on NVIDIA H800, which is what they use, is limited to retaining around 14 bits, which is significantly lower than FP32 accumulation. So this is even worse when the inner dimension is large. So basically they found a hardware limitation that makes the precision even worse. So what their solution is to use a hybrid approach. So they use Tensor Core plus CUDA Core. Usually everyone just use Tensor Core, and CUDA Core is, to my understanding, it's one layer down. So to overcome the hardware limitation, DeepSeek moves some of the accumulation outside the Tensor cores. So the matrix multiplication kernel performs each series of 4 consecutive WGMMA. That means asynchronous war group level matrix multiply and accumulate operation. So you don't have to know the details about it, but just know this is one of the policy of NVIDIA's hardware for matrix multiplication and the value accumulation. So the operations inside the Tensor cores, but accumulating in the lower precision format. But then they add the results into a separate register-backed accumulator tensor in FP32. This happens in CUDA cores. So this mitigates the loss of accuracy. And on the right, this is a graph of how they achieve this. Okay, this is how DeepSeek use FP8 mix training pipeline and Tensor Core plus CUDA cores to overcome the limitation, so that they require less resource and fast within their budget. Hope this is helpful. Thank you very much.